Section 7.3, extra example number 7. This is about the mean number of texts sent by a randomly selected Homestead High School student. So let's say it follows a right-skewed distribution with this mean and standard deviation. How likely is it that a random sample of 50 students, n equals 50, will have sent greater than 1,000 texts in the last 24 hours? So we're going to do state plan view conclude. We're trying to find the probability that that x bar, so we want the average of 50 students, x bar is greater than 20, because we have 50 students, a total of 1,000 texts, so that's 20 texts per student. So 1,000 over 50, x bar is greater than 20, where x bar is the sample mean number of texts. So our plan is, okay, so the population distribution is not normal, but the central limit theorem kicks in here because the sample size is greater than 30. So I'm going to write this out. Population distribution is not normal. They specifically say that, but by the central limit theorem, since our sample size n greater than 30, then the distribution of x bars, the sampling distribution of sample means, the distribution of x bar is approximately normal. Approximately normal, and the mean of the sampling distribution of x bar is 15. The standard deviation is the population standard deviation over the square root of the sample size. So we'll use that in our calculation. And now we're going to do our calculation. So normal CDF, from 20, we want greater than 20 to infinity. Mean, and here's our standard deviation from above. And you should get, try it yourself, but you should get 0.1562. And so there's about a 16% chance that a random sample of 50 students will have sent greater than 20 texts. Per student. So there is a 16% chance. A random sample of 50 students will have sent greater than 1,000 texts in the last 24 hours.